Thank you, Ella, for that lovely introduction. And I just want to say that I have been looking forward to this panel all week. I myself am a huge reproducibility nerd. I think that one of the things that we can do through the space of blockchain and decentralization to have a large positive impact on the world is build protocols, build applications that enable streamlined data, information, and knowledge management in a way that can enable better, faster, more reproducible research. But I'm just one of three folks, or one of four folks on this panel, and would love it if maybe the three of y'all could just quickly give an intro to who you are and why you care about reproducibility in academic research.
All right, I'll go ahead. So my name is Edvard Hübinette. I work for DeSci Labs as a protocol architect. I've always been super interested in reproducibility in most senses, I guess, mostly from like functional programming to like pure build systems. Then when I found DeSci, I found this to be like a really intriguing application of the Web3 ecosystem. Since then, been getting deeper and deeper into the nooks and crannies of meta science, and I just find it to be like a super interesting field.
Okay, it's my time. I'm Žiga Drev, one of the co-founders at OriginTrail. And OriginTrail's crucial technology is called decentralized knowledge graph, which can be used to advance the trusted knowledge foundation for decentralized science as well. It's not a new project. We launched it already back in 2014. It debuted in supply chains. And then we figured out that the same technology could be used to drive verifiability of data within transportation. So we went from corn to transportation, and recently the technology has also ventured into the adult industry. So in a way, going from corn to porn, and now the same kind of elements could be used potentially to very much advance and learn from things that we have learned in porn industry and things that we have learned in supply chains for the benefits of decentralized science. So how can we include inclusivity and also improve reproducibility within the science?
Hi, I'm Warren. I'm DRIPS's head of data. Before joining DRIPS in March of this year, I mostly worked in data science at SoundCloud, and I actually started out my career as a researcher in psychology and developmental neuroimaging, which are both fields that are quite severely afflicted by the reproducibility crisis. So they're dear to my heart, and it was really interesting for me to kind of like step out of school and into a career doing research in fields that were starting to unearth a lot of failures to replicate things that I presumed I had learned. And yeah, now that I work at DRIPS and we're like extending the protocol to support funding researchers to their ORCID profiles, I'm really excited by the opportunity to use this flexible funding primitive to shift some incentives towards better research practices.
Absolutely. And just want to say I'm very excited to have all three teams and pieces of technology on this stage. So DeSci Labs was the first group that I worked with in the DeSci space. In my time at Labs, spent a lot of time working with FAIR and the concept of knowledge graphs. And believe it or not, DRIPS funding was the first thing that got me to think about how incentive structures can have a meaningful impact on science coming from the decentralized web. So one question that I would love to ask to all three of you, in whatever order it comes in what ways do blockchain and decentralization play a meaningful role in pushing towards open and reproducible science? And by the way, for those in the room who may not be familiar with the term reproducible science, the idea is that whenever a researcher publishes a manuscript, someone can follow the methods that were actually put in the paper and in any supplementary artifacts and come to the same conclusion. So that is a rough definition of reproducibility. But Edward, I see you got the mic. What are your thoughts on that?
Yeah, so to have a reproducible research publication, it needs to be stable for a long period of time. Because if you, as another researcher, want to try and reproduce the results, but you don't have access to the artifacts necessary from the initial publication to even try that, then that's going to be a very rough time. And we've sort of, from the legacy of like the printing press, the main vessel for communicating scientific progress has been like the paper page, now in digital format, the PDF. But it still doesn't support, access or sharing to the rest of the artifacts that are necessary to reproduce the results. And a cornerstone of the scientific principle is to communicate your work in such a way that another interested party can go through it and perform the same methodology to either end up at the same conclusion or a result that's contrasting to that. And that's also an interesting addition to science. But for any of this to be possible, we need to have an efficient way of sharing and referring to content that was part of publications, ideally without being strongly dependent on any particular actor still being around or the person still working at the same institution. So through the primitives that we have in this space, we have content address data systems, we have stable ledgers for holding references, we have strong technology for versioning publications. We basically have all of the pieces that we need to put this together in a neat way to at least remove as many obstacles as possible for a scientist to publish a work that is as reproducible as possible.
Absolutely. And I think it's fantastic to think about how, to a certain extent, that kind of needs to be on blockchain or on some kind of a shared infrastructure, especially as we see some of the, shall we say, funding issues that have come from the US research space. And especially as we see some of the challenges in the legacy system with cross-organizational collaboration. The idea of having this open and decentralized knowledge layer is just so incredibly powerful. But whenever I think of a DeSci node, one of the things that I really think of is a little graph of information, a graph of knowledge. So it's the manuscript, but it's the video, it's presentations, it's, we'll say, code files, data files, and having that full chain of provenance is really important. So maybe a question for Žiga, as we start thinking about the impact of why blockchain is necessary for this kind of open and reproducible work, I would love to hear a take on how knowledge graphs play into this larger space.
Yeah, there are more ways to look at it. One important aspect is definitely democratization. You touched upon the problem of or the issue of funding science right now in the US. With blockchain or decentralized systems, there is always much more democracy to deciding what kind of science should be financed, and there is no central actor that could prevent funding of a science if science is meant for the betterment of mankind. So that's, let's say, a political reason removed for science not to be funded or for science to be developed in a less democratic way, in a biased way. And then secondly, now at the advent of AI agents, we see that also AI is running out of public data. So we're on a cusp of having to decide whether or not we're going to be developing more private AI solutions or more public, inclusive AI solutions. And why is that important is because as we run out of public data, the AI will necessarily focus a problem of a model collapse. And that's something you don't want to have in science. So more and more synthetic data and less optimal results by utilizing AI. So we need to figure out how to bring more data on board, more sensitive data on board. And if you want to do that, again, you need to somehow incentivize people to come together to contribute their sensitive data. And even when they're contributing sensitive data, it should be done in a way that no sensitive data is, let's say, exposed via sensitive channels. And it does seem that centralized ways of maintaining data or knowledge are also very much prone to, to all those vectors of attack where data can also be exploited, also sensitive data. Yeah, so, and also kind of unearthing some of the methodologies that exist across the board, so not within a single company, not just the data, but also techniques of utilizing the data. I mean, there's a crazy side thought I had here that perhaps there are even some technologies that exist right now in the adult industry that could be used for the benefit of science. For instance, there's a way to identify IP thefts by using a special method called perceptual hashing. And the same technology could be used to identify some similarities or percentage similarities between CT scans. So again, kind of bringing aboard different technologies from sectors which are not intuitively linked to decentralized science can be done via such a decentralized way of discovering how science could be improved.
And just to drill into that a little bit more, because I think from the standpoint of knowledge graphs, this is so critically important. As we start to think about more trusted AI, and as we start to think about some of the challenges in cross-disciplinary research, let's say, and just to give an example for the folks in the room, it can be very, very difficult for researchers to speak across different domains. So as a researcher in quantum physics, you may go into biology and see a very similar phenomenon to what you have observed in your PhD in quantum physics. This example, by the way, is based on a group called Quantum Biology DAO, where this exact thing happened to a researcher. So would love to hear about maybe how knowledge graphs can help a little bit more with that cross-disciplinary translation aspect between different domains of research and in a trustworthy way.
Yeah, so in a way, how can we achieve serendipities in a little bit more systematic fashion? I just heard from a colleague yesterday that Viagra initially was not invented in order to, cure the stiffness, but instead to cure the blood pressure, if I'm not mistaken. Apologies for the wrong interpretation. So how can you plan and anticipate some serendipities and then build your way back from serendipities and perhaps even discover a drug that could be used for multiple purposes? So this is something that could be achieved via such a decentralized way of functioning when you have experts from several fields with intention building their way back from serendipities to a single, let's say, solution that spans and can solve several challenges across sectors. But let's leave it to Warren to see what he has to say.
I just want to say it must have been quite the shock for the people in that clinical trial.
On that question about like interdisciplinarity and knowledge graphs, or
No, more so on the question of why blockchain is necessary for or is important for reproducible and open research.
Yeah. Yeah, I don't have a ton to add on to what's been said so far, but I would say, like, just in general, the properties of immutability and censorship resistance, like, kind of lend to indispensable virtues you need in a data store that you don't have to trust through some, like, proxy, like institutional prestige, but you can actually just verify that every input and every plan, every input, every processing step, every output across the life cycle of a study is as it was described in the publication, and that you could reproduce that. And I think, if you're doing that in, just some database hosted on S3, then, good luck getting the property of verification without trust.
No, absolutely. And especially as we think about research, somebody looking back at the scientific record 20 years from now, that S3 bucket is not going to exist. And that is such a huge problem, this kind of link rod, content drift. So I could not agree with you more. So shifting over maybe to a different question, because we've got three things in the name of the panel. How does blockchain help push reproducible and open science? How do agents help push reproducible and open science? And how can incentives help push reproducible and open science? So to maybe shift on to the next point of this, we have seen such a massive shift in the capabilities of AI over the past, 3-4 years at this point. There's been a lot of conversation around using AI for academic research. Groups like Future House, Biomni, and last but definitely not least, Bioprotocol are working on trying to solve some of these problems and trying to enable scientific agentic researchers. So part of what I would like to ask is, what major shifts in science do you see coming from this larger agentic wave? And what's needed to make sure that those shifts push towards openness and reproducibility?
So I think there's a few takes on this that I'll focus on that I think are a little more grounded than some of the other ideas I have. One is like the lowest hanging fruit is like a lot of scientists don't share their code because they don't have formal programming training, and they're understandably anxious of being negatively evaluated for writing messy code that has bugs and doesn't have documentation. But we're at a point now with agentic coding assistants that's so good that that disincentive should practically be removed. So that's one thing that's just like a free, nice side effect of everything that's happening in, whether it's open or closed source AI. So that's nice. And then, things like yes, no error, like doing like at scale error detection should hopefully help like shorten the time to retraction, and like the insane amount of time it takes for like a study that has major flaws in it to get retracted, and then for those retractions to be like indexed by PubMed is absolutely insane. So hopefully that type of thing is going to help a bit with like preventing error from cascading through the record. But I'm interested in like how agents could play certain like methodological integrity compliance check roles along the stages of a research pipeline, so that you don't have to hire humans per se to, be the compliance ompt for checking that like a researcher has pre-registered their study and that like the methods they said they would follow and the analysis plan they said they would follow, they actually followed, and every piece of code that's submitted as it's like every piece of code in every version and every intermediate stage of the data set that's collected is not being tampered with, so that when you combine that with something like DRIPS, which has the ability to continuously stream funding to a research group and their dependencies, and to pause or augment those funding streams through conditional checks by an agent like that, that you can systematize a schedule of reward that incentivizes good research practices automatically. And I think that's something I'm really interested in. And then like the next step of that would be, if we have agents that can do computational reproducibility perfectly, which we don't yet, then having all the source code and the environments and the libraries that it used, plus the data, and if the agent can then reproduce it, then maybe the researcher gets a little bonus.
No, absolutely. And just to add on to that, it is so brilliant to think about the fact that increasing the amount of information that you publish for an agentic researcher who has the ability to go through just a wide volume of information, then increases your surface area for citation, increases your ability to continue to accrue credit, which I don't personally believe we should move towards citations as the sole metric in the future, but your ability to accrue credit based off of that. And DRIPS is a fantastic potential incentive model for working towards that. Yeah. So yeah, couldn't agree more. So, and Žiga, I'm gonna alter the question for you just a little bit. I asked everyone else open and decentralized science. What I would love to hear from the standpoint of OriginTrail is about open, decentralized, and verifiable science. How do we make more trustworthy agents that are better able to handle the precision and the larger context required from scientific research?
That's a good question. I hate to break it to you, but decentralized knowledge graph does it. Okay, it's just one of the first steps, I guess. It's one needs to have access to quality data, and if quality data is not persistent, then you can have a perfect ontology. You can have a perfect way of scaling decentralized infrastructure, and nothing will actually happen. What we can do is we provide means for garbage in and not exponential garbage out to take place once you have high-quality data, once you have highly structured data, once you apply the right semantic approaches. And then verifiability, what is also quite important to hear, and it was pointed out by Warren, is that you are able to attribute each participant's contributions. You know, it's so that the situation at the end of the day is not like those high school assignments where you have 4 dudes working together, but actually just one is working and, you know, they all get straight A's. Yeah. So by having sort of a decentralized knowledge graph, you can also, in an immutable fashion, attribute and point out what were each one participant's contribution. Now that's, when it comes to humans, that is perhaps a little bit easier, but when you have a swarm of agents working on a solution, working on a medicine, you know, one has to provide even better and more sturdy way of accounting for, you know, each agent in a swarm contribution, because they all must have had like different energy consumption. So all of these things need to be somehow accounted for. And again, decentralized ways of doing it via decentralized knowledge graph can also allow for that, so that you can, you know, post when research is done, when it's already being successfully funded, you can then, you know, attribute as to who deserves most. And this is, it's not easy. It's very hard to do that in today's world with traditional techniques.
I can just want to echo that. I mean, it is incredibly challenging to even try and think about ways that more traditional legacy systems would be able to attribute that credit in a more fractionalized fashion, even across human researchers, much less agentic. That's an excellent point. Thank you. Edward, what are your thoughts?
Yeah. So I think something that's really important when we're talking about like agentic research is that we, at least the same speed, need to enable agents to sort of validate and sort through and filter through that content. Because if we're going to have, like, in the current system, the scientific community has a lot of issues managing there's like 1 million scientific papers published each year, and we can't handle the volume already. So if we spin up a bunch of agents that's spitting out, you know, like 1 million research ideas every month, week, day, hour, like how are we going to be able to like manage that volume? So we need to also make sure that we have agentic actors in place to like do that filtering and like figure out like what of these are like promising avenues to go down, because otherwise we're just going to drown in half-finished, you know, research ideas. And I think that might be a very tricky swamp to navigate.
It'll be interesting to see as this move forward and as people continue to progress through a lot of this, but totally agree and agree with some of the earlier points about knowledge graphs playing a very important role in that verifiability. I think on the flip side of that, we also see a future where we really can accelerate scientific progress, and I believe it was one of Sam Altman's most recent blog posts around how he personally sees the biggest disruption from AI coming in the space of scientific research. But it's going to be a little while, I think, before we get there, so working on that hard and fast. So we are actually a little bit over time on the panel, but I'm actually hosting the next session, so I'm going to be greedy and take from that session to give to this one. If y'all don't mind. Edward, I do want to give you a chance to quickly, because I think both Žiga and Warren have kind of already answered the question on how do incentives help fix or push us towards open and reproducible research. But I wanted to give you a quick chance to answer that same question as well.
Absolutely. So we think a lot about the existing incentive structures in science over at DeSci Labs, and in particular around peer review, or like the generalization of like, you know, quality evaluations. Because in the current system, this is all like implicit, it's like an implicit public good, where there is a huge free rider problem and there is an absurd amount of work that's being performed every year. I pulled some numbers for the workshop I held earlier. I think just the US, the UK, and China in 2020 spent over 1 million hours of researcher time doing peer review. That's 15,000 years of work that is unpaid, which roughly translates to like $3 billion donations of like free labor to the publishing industry. And like the top 5 publishers, they have a combined revenue of like $12 billion a year at a like 40% profit rate.
And correct me if I'm wrong, that's higher than Google, that's higher than Apple, their profit margins.
I mean, it's absolutely astronomical. In the same sentence, they're saying like it would not be like financially viable to like actually incentivize peer review by paying reviewers. So I think we have a fairly unique opportunity in the Web3 space to find new methods of incentivizing science through the like financial fundamentals that we have present. And yeah, you know, figure out ways to make peer review a worthwhile task to work on and make it visible. Because right now, the only way you can like get tenure and get respect within research is just publish papers in high-impact journals. Mm-hmm. And we're getting super skewed by their own biases towards, you know, like high-impact science and like highly citable science. So all of these sort of like skew us away from doing reproducibility studies and, you know, like other acts of tending the scientific garden, like data stewardship and, you know, like just managing metadata, like all of the things that we would need to have like a highly functional scientific record. All of this is just like invisible work, and it's pretty thankless. But in this space, we have the opportunity to let people build up like credibility and tenure, and like make that work visible and make that work rewardable, and like hopefully with something like GRIPS on top of that, you should be able to like find new ways of funding work that is important and it is very valuable for the scientific record, but is invisible in the traditional system.
Couldn't agree more. Just wanted to quickly thank all 3 of you for coming up on this panel, for coming to Berlin, for giving the time. Also, Žiga, thank you for the sponsorship of OriginTrail at the BioX AI Hackathon, which is the next session that we have coming up. So with that being said, thanks, guys.